Hello and welcome. Today, we're going to dive into one of the most mind-bending questions out there. Is our reality, well, real? We're going to take a journey from a pretty wild philosophical idea to the absolutely bizarre science that makes it seem kind of plausible, and then to the world-changing tech that's being born from it all. I mean, have you ever had that feeling? That little thought in the back of your head, something straight out of a movie like The Matrix? The idea that maybe, just maybe, the world you see, hear, and touch isn't the base reality. What if it's all just code? This isn't just a late-night philosophical debate anymore. Some very serious people are actually considering it. For instance, you've got tech leaders like Elon Musk, who famously said that the odds are overwhelming that we're living inside a computer simulation. Now, that's a huge claim, right? But it's actually rooted in some surprisingly compelling science. So let's dig in and find out why. Okay, to really get why this simulation idea has some legs, we have to travel to the strangest corner of physics, the quantum world. This is where reality itself seems to have, for lack of a better word, a glitch, something that just does not behave in a way that makes sense in our everyday world. It all comes back to a famous experiment in quantum mechanics known as the double-slit experiment. The idea behind it was pretty simple. You shoot tiny particles, like electrons, at a screen that has two little slits in it, and you see what kind of pattern shows up on the wall behind it. The results, though, were anything but simple. And here is the crazy part. When nobody is looking, the electron acts like a wave. It creates a pattern on the wall that shows it somehow went through both slits at the exact same time. But, and this is the kicker, the moment you put a detector there to see which slit it goes through, its behavior totally changes. It suddenly acts like a particle and picks just one path. The simple act of observing it literally changes the outcome. This is where the simulation theory connection really clicks. Think about a massive open-world video game. To save on processing power, the game doesn't render the entire world all at once, right? It only renders the stuff the player is actively looking at. So, some physicists wonder, does our universe do the same thing? Does it only bother to define reality when an observer, like us, forces it to? Now, this bizarre quantum behavior isn't just some philosophical oddity. No, it's the very principle that's powering a new, absolutely revolutionary technology, quantum computing. So what even is a quantum computer? Well, to put it simply, it's a machine that uses those weird rules of the subatomic world, like particles being in multiple places at once, to solve problems on a scale that we could barely even imagine before. The secret sauce here is the difference between a classical computer bit and a quantum bit, or what we call a qubit. Your phone, your laptop, they all use bits. They're like light switches, either on, a 1, or off, a 0. Simple. But a qubit? A qubit can be a 0, a 1, or somehow both at the same time. This mind-bending property is called superposition. And that is what makes it so unbelievably powerful. Because a qubit can explore all these different possibilities at once, a quantum computer can perform a massive number of calculations all at the same time. Think of it like this. A normal computer tries to pick a lock by testing every key one by one. A quantum computer can basically try a huge number of them all at once. And as you can probably guess, that kind of incredible power has kicked off a brand new global competition. We're talking about a high-stakes race, just like the space race or the arms race, to be the first to truly master this technology. Because whoever gets there first is going to have a massive advantage. The starting gun for this whole race really went off back in 2019. That's when Google announced its quantum processor, named Sycamore, had achieved something called quantum supremacy. It performed a very specific calculation that was, for all intents and purposes, completely impossible for even the world's most powerful supercomputers. And when I say impossible, how impossible are we talking? Well, Google estimated that Summit, which was the fastest supercomputer on the planet at the time, would need about 10,000 years to do the same calculation. And how long did Google's quantum computer take? Just 3 minutes and 20 seconds. Let that sink in for a second. A task that would take a machine thousands of years was done in the time it takes to make a cup of coffee. That's the kind of power we're talking about here. It's a total game changer. And now everybody wants in on the action. The US is a huge player, of course, with giants like Google, IBM, and Microsoft all in the game. But China is moving incredibly fast, and now holds more than double the number of quantum patents as the US. And you've got countries like Japan and Germany pouring in money, with their biggest corporations all teaming up to get an edge. So why is everyone in such a frantic race? Well, it's because this technology is the ultimate double-edged sword. It could hold the key to solving some of humanity's biggest problems, but it also has the power to create chaos on a scale we've never seen before. On the one hand, the promise is just breathtaking. Imagine creating new life-saving vaccines in a matter of weeks, not years, or designing revolutionary new materials from the atom up, developing truly intelligent AI, or accurately forecasting climate change. But then there's the other side. The peril is terrifying. A powerful quantum computer could almost instantly break all the encryption that protects everything: your bank account, your private messages, global financial systems, national security secrets. It would make digital privacy a thing of the past, overnight. A really good way to think about this is to look back at Alan Turing's code-breaking machine during World War II. His early computer, which was super simple by our standards, cracked Germany's unbreakable Enigma code. And that one breakthrough is estimated to have shortened the war by 2 whole years, saving millions of lives. The strategic advantage we're talking about with quantum computing is on that level, and probably even bigger. So, this brings our whole journey full circle. We kicked things off with a pretty strange question about whether our reality is real, and it's led us to a technology that will give us the power to fundamentally change it. Isn't that just a fascinating thought? We started by asking if our universe is basically a simulation, a reality built on code. And what we've discovered is that through quantum mechanics, we are on the verge of becoming the coders. We're learning to manipulate the fundamental building blocks of our reality to solve problems we used to think were impossible. So, at the end of the day, maybe the question of whether our world is a real or a simulation isn't even the most important one. Science might never actually be able to prove it one way or another. So, what does that leave us with? What should we focus on? Maybe the real takeaway here isn't about whether we live in a simulation, but the incredible fact that we can even ask that question. That drive we have to explore, to learn, to decode the deepest secrets of our own reality, that's what really matters. And with the power of quantum computing just over the horizon, we're not just exploring our reality anymore. We're about to start writing its next chapter. Thanks so much for joining me.
Health is the most precious gift. If this video helped you or someone you love, please like, subscribe, and share so more families can stay safe and healthy.